Good morning friends. Today we will discuss the more about or detail about ionic bonding or electrovalent bonding. In the last session we saw the basics of ionic bonding. We saw the electron dot structure of NaCl. There are three types of representations of ionic bonding: equation method, electron dot structure and electron orbital diagram. So there are basically three types. In the last session we saw ionic method of representation of NaCl compound. Now we will move forward, and for the same compound NaCl we will draw the electron dot structure and we will draw the electron orbital diagrams. So the next lecture would be, that is second one, and it is electron dot structure of NaCl, or the formation of representation of NaCl compound with electron dot structure or electron dot compound, electron dot representation. So the basic thing for electron dot structure is that in electron dot structure only outermost electrons are represented. Only and only outermost electrons are represented, and not the other electrons, that is antipenultimate shell or penultimate shell. Only the valence electrons are represented by different symbols. So for in case of NaCl, we are going to have Na, which is our sodium, and sodium has one electron in its outermost shell. So I am representing that one electron which is present in the outermost shell with this cross sign, and the electronic configuration of sodium is 281. Now the second compound is chlorine, and chlorine has 7 electrons in its outermost shell, and I am representing those electrons with the dots. So it represents that sodium has only one electron in its outermost shell, and these 7 dots represent that chlorine has 7 electrons in its outermost shell. So the electronic configuration of chlorine is 287. Now, since sodium is electron donor, sodium will donate its one electron to the chlorine atom. It will donate one electron to the chlorine atom, and because of that, this sodium will be converted into Na plus cation, because it will donate one electron and will be converted into sodium plus cation. And at the same time, this chlorine atom will accept this donated electron and it will be converted into Cl, and since it was already having 7 electrons in its outermost shell, and the one which it got accepted from sodium, which I am representing with cross, and this whole will develop a negative charge because it is now sodium cation and it is now sodium anion. So the electronic configuration of sodium would be 2A and chlorine would be 288. Fine. So now we have sodium cation and chlorine anion. So after that, these two types of ions, that is cation and anion, get linked by electrostatic force of attraction. This dotted lines represent electrostatic force of attraction, and the resultant is NaCl molecule. So this was a representation of NaCl bonding with electron dot structure. So in case of electron dot structure, first of all we have two elements, that is sodium and chlorine. So our sodium is our metal and chlorine is our non-metal. Sodium has the configuration 281, and in case of electron dot structure we represent only the outermost electrons. So sodium atom, which the electron which is present in the outermost shell is represented by this cross, and chlorine has 7 electrons in its outermost shell. So the 7 electrons are represented with these 7 dots. So it has a configuration 287. Now sodium donates this electron and chlorine accepts this electron which is donated by sodium. Now this sodium, after donating its 1 electron, gets converted into sodium plus cation, and chlorine, after accepting this electron from sodium atom, gets converted into chlorine anion, Cl minus anion, and chlorine was already having 7 electrons in its outermost shell, and this cross represents the electron which was donated by sodium. Now the two ions, that is sodium cation and chlorine anion, gets linked by electrostatic force of attraction. These dotted lines represents electrostatic force of attraction, and this leads to the formation of NaCl compound. So this was the electron dot representation of NaCl compound. Okay. Now we will see the third representation of ionic compound, that is electron orbital diagram. So we are moving forward to the third type of representation, that is electron orbital diagram. So we are going to discuss electron orbital diagram of NaCl, sodium chloride. So when we are going to represent electron orbital diagram, in this case all the electrons are represented, not the outermost as was the case with electron dot, but in case of electron orbital diagram all the electrons are represented, all the shells are represented. So basically we have two elements in our NaCl molecule, that is sodium and the other one is chlorine. So let us draw the electronic structures of both the levels, both the atoms. So first we will draw for sodium. Now, so this is sodium atom having electronic configuration 281. So I am going to represent the electrons with cross 2, 8, and this is 1. The next is chlorine atom having electronic configuration 287. So I am representing the electrons with dots. So these are the sodium and chlorine atoms having electronic configuration as 281 and 287 respectively, both the atoms we have drawn. Now this outermost electron which is present in sodium, it is donated to chlorine. Now this is donated to chlorine atom so that it will be converted into Na plus cation, and chlorine atom will be converted into Cl minus anion. So the next step would be, now we are discussing about ions. So again this is our sodium, and the next one is chlorine, that is ions, sodium and chloride ions. So it will have 2 electrons and 8 electrons. So this is Na plus atom having electronic configuration 28, and this is our chloride atom having configuration 288. So these are the molecules, and this cross represents the electron accepted by chlorine from the sodium atom. So this is our Cl minus atom, and now it has 288 configuration. So this cross represents the electron accepted from sodium Na. Now again, this overall species will have a negative charge, and this will have a net positive charge. Again, this sodium ion and chloride ion which are present, they will be linked by electrostatic force of attraction, and hence NaCl will be formed as an example of ionic or electrovalent compound. So in the next step, we would have sodium Na plus ion and Cl minus ion, and both the ions would be linked by electrostatic force of attraction, and as a result NaCl compound will be formed as an ionic compound. So these dotted lines represents electrostatic force of attraction. Electrostatic force of attraction. So this was the last representation of electronic orbital diagram of NaCl. We took one example of ionic compound or electrovalent compound, and that was of NaCl. We saw that for ionic compounds or electrovalent compounds, we can have three types of representation. First was for ionic method or ionic representation, equation method. Second was electron dot structure, and third was electron orbital diagram. So we saw all the three representation by taking NaCl as an example. So in the last example, in case of electron orbital diagram, we represent all the electrons or the shells are represented, not only the outermost shell as was the case with electron dot structure. But in this case, all the electrons are represented, all the shells are represented. So let us take one example. This is our sodium atom having configuration 2, 8 and 1. So these are the shells. Then comes chlorine atom having electronic configuration 2, 8, 7. Since this chlorine atom needs one more electron to complete octet, so the sodium atom, since it is a metal, it will donate its one electron to the chlorine atom. As a result, this sodium will be converted into Na plus cation, and this chlorine atom, after accepting this electron from the sodium atom, will be converted into Cl minus anion. After that, this sodium atom, this sodium Na plus cation and Cl minus anion will be linked by electrostatic force of attraction, and as a result NaCl is formed as an example of ionic or electrovalent compound. So we saw the entire thing about ionic or electrovalent compound, electrovalent bonding. We have three types of representation in ionic or electrovalent bonding. First one was electron dot structure, equation method, and then electron orbital diagram. Thank you.